To keep things as simple as possible when we're analyzing the effect of a rotation on the coordinates of a shape, we're going to keep it real simple. We're only going to look at multiples of 90 degrees, and we're only going to look at rotations around the origin. If that point is in another spot on the coordinate grid, and if we have angles of rotation that are something other than multiples of 90 degrees, so 90, 180, 270, the math becomes high school level math to figure out where those points would land. So let's look at our first rotation, a counterclockwise 90-degree rotation. So when you slide the green dot, our rotation looks like that. So same shape, same size, just rotated around the origin as if those points were attached to the hands of a clock, just rotated around the origin 90 degrees. If we do that again, there's our 180-degree rotation. So it's halfway around the circle. Again, same size, same shape, just rotated 180 degrees. And then 270 degrees is right there. You get to 360, you are back to the start. So in OneNote, I kind of put these all together into one diagram so you can see each rotation, and you can check your work on your coordinate points using this data table. They were also listed in the GeoGebra app. And I just wanted to show, though, what's happening to the coordinates. If you didn't notice this, what's happening to the coordinates every time we rotate them another 90-degree angle. So our first 90-degree rotation, takes us from the original shape over to there. And so notice, when you look at the coordinates, notice what's happening as you go from the first row to the second row. Notice what happens to each point, not just one point or the other, but to every single point. Notice what's happening is every time the x and y coordinates are switching place. So 1, 2 becomes 2, 1, 2, 4, 2, 4 becomes 4, 2, and 4, 1 becomes 1, 4, although one of them changes sign. And that makes sense because if you rotate it 90 degrees counterclockwise, and you land in the upper left quadrant, x is negative and y is positive there. First quadrant, you have positive x and positive y. And so x and y switch sign, but the signs on those match the coordinate that they're landing in. When we go another 90 degrees, so now we're looking at going from here over to there, notice they do the same thing. When you go from the second row to the third row, notice x and y switch again, and then there's another sign change. This time the shape lands down in the bottom left quadrant where you have negative x and negative y. So in the third row, all of your x's and y's are negative. And they've again switched from the previous one. If you look at the top row to the third row, from the original shape to the 180 degrees, notice that's a double switch. Every 90 degrees, x and y switch place. So they've switched back to the original spot, but now their signs are different because you're in that lower left quadrant. And then our final rotation of 90 degrees takes us all the way around to there. And so again, looking from the third to the fourth row, you'll notice x and y switch again. Every 90-degree spin switches your x and y, and there's another sign change. This time you're landing down in the bottom right, where we have positive x's and negative y's. So all of our x's are positive, all of our y's are negative. So just to recap, what's happening here, I'm going to recap this just under number 7, is that each 90-degree turn causes your x and y coordinates to swap places. Okay, so if you have your X and your Y, they are switching spots. So they swap places. And the resulting sign on your coordinates matches the signs of the quadrant that the shape lands in. Okay, so I tried to make that description kind of applicable to any starting quadrant. Um, but notice it works for each of the 90-degree rotations that we looked at. So even if it started in the bottom left quadrant, down here, if we did a 90-degree turn up to here, X and Y would switch, but X would be negative, Y would be positive. If we were to start in the lower left quadrant and go 90 degrees over to here, X and Y would switch, you'd have positive X's and negative Y's. So every 90-degree change, X and Y swap places, and the signs on X and Y match whichever quadrant it's ending up in. So that kind of covers descriptions of rotations starting in any quadrant.